Welcome to The Explainer. We hear about artificial intelligence literally all the time, but have you ever wondered how a project actually gets built? Today, we're going to pull back the curtain and go from just a simple idea to a working program. We're going to create a blueprint in our minds for how any AI project really comes to life. So, let's dive in. Okay, so every great AI project doesn't start with a line of code. It starts with a problem, a real-world problem. So, picture this. A farmer is watching all their hard work get eaten away by pests. Now, this isn't just about losing a few plants. This is about their livelihood. It's about the food that ends up on all of our tables. So how can technology actually step in and help? This is the perfect kind of challenge to see where AI can really shine. All right, so we have our problem. But to solve it, we're going to need the right tools. I want you to think of AI as this massive, incredible digital toolbox. And before we can start building anything, we got to open it up and see what's inside. So let's start with the big question. What is artificial intelligence, really? At its core, AI is really just about making machines think. It's about giving computers the power to do things that we usually associate with, a human brain. Things like learning from experience, figuring out puzzles, and even making some pretty tough decisions. It's not some kind of magic, it's the actual science of building a digital brain. This right here is a perfect way to picture how all these buzzwords fit together. Think of it like a set of Russian nesting dolls. AI is the biggest doll. It's the whole field. Now you open that up, and inside you've got machine learning. That's a way to do AI, where you feed the computer a ton of data and let it learn on its own instead of you programming every single rule. And then you open that doll, and inside you find deep learning, which is a super powerful type of machine learning that uses these complex networks, kind of like the ones in our own brains, to spot really subtle patterns in data. So AI isn't just one thing. It's more like a collection of specialized skills. And for our farmers project, and really for almost any AI you interact with every day, there are three big areas we need to get our heads around. Just think of them as the core abilities of that digital brain we're talking about: seeing, speaking, and analyzing. First up, we've got computer vision, and it's pretty much exactly what it sounds like. We're giving machines the power of sight. You know when your phone unlocks just by looking at your face? Or when you can search your photos for cat and it finds all of them? That's computer vision. And for our farmer, this is a total game changer, right? We need our AI to be able to actually see the difference between a healthy crop and one that's being attacked by pests. Next is the analyzing part of the brain. This is where the AI becomes a kind of super detective. It just digs through mountains of data to find hidden patterns and make really smart predictions. I mean, have you ever wondered how your favorite streaming service just knows what movie you're going to want to watch next? Well, this is the part of AI that's doing all that heavy lifting behind the scenes. And finally, we give our AI a voice and ears. This is done with something called natural language processing, or NLP for short. This is the magic that lets machines understand what we say and what we type. So every time you ask your smart assistant for the weather, or your phone automatically fixes a typo for you, you are using NLP. Okay, so we have a problem to solve, and we have a toolbox packed with these incredible AI skills. But you can't just throw tools at a problem and hope for the best. You need a plan. You need a blueprint. And in the world of AI, that blueprint has a name: the AI project cycle. Now, this isn't just some boring checklist. It's a living, breathing cycle. We start by really nailing down the problem. Then we go on a hunt for data. That's the raw material our AI is going to learn from. After that, we build our model, we test it, we refine it, and then finally we set it loose in the real world to do its job. It's the entire roadmap from a question to a solution. So let's actually walk through this, starting with step 1, problem scoping. And listen, this first step is absolutely everything. If you mess this part up, even the most powerful AI in the world is going to fail. This is where we have to stop and ask ourselves, what are we really trying to do for our farmer? So how do we make sure we get this right? Well, there's a really simple but incredibly powerful tool called the 4Ws problem canvas. Its whole job is to cut through all the noise and force us to answer 4 basic questions: who, what, where, and why. This little exercise is how we turn a fuzzy idea into a crystal clear target. And look, let's just apply it to our farmer's problem. Who are we helping? The farmer and the whole agricultural community. What is the actual problem? It's crop damage, which leads to financial loss. Where is this happening? In the farmer's cotton field. And then the most important one, why do we care? Well, because solving this will boost their crop yield, improve their life, and help make sure we all have food. See, in just 4 questions, we've gone from a vague idea, let's help the farmer, to a concrete mission.
Okay, with that clear mission locked in, we can finally start building. And that starts with one thing: data. For our project, that means we need to get our AI some textbooks. We need to gather thousands and thousands of pictures of plants. Some of them are going to be healthy, some are going to be infested with pests. We then feed this whole visual library to our AI model, which is the program that's going to learn to spot the difference. But building the model is really only half the battle. Now comes the hard part. We have to test it. Think of it like giving our AI a final exam. We show it a whole new set of pictures it has never, ever seen before. Can it still spot the pests? Does it get confused? This is the moment of truth. This is what tells us if our AI is actually ready for the real world.
And this whole reality check, this testing phase, it naturally leads us to something incredibly important we have to consider: ethics. As we're building these unbelievably powerful tools, we have to hit the pause button and ask some really tough questions. Just because we can build something, does that always mean we should? One of the biggest dangers out there is something called AI bias. This happens when the data we use to train our model is lopsided or incomplete. So, for example, if a facial recognition AI is trained mostly on photos of men, it's going to be way less accurate at identifying women. It's a pretty simple concept. Biased data goes in, biased results come out. The AI isn't trying to be unfair, its entire worldview is shaped only by the data we give it. And this brings us to maybe the biggest question of all: accountability. If a self-driving car gets into an accident, who's to blame? If our farmer's AI messes up and recommends something that ruins a harvest, who is responsible? Is it the programmer who wrote the code, the company that sold the software, the farmer who decided to trust it? Honestly, there are no easy answers here. But as AI gets woven deeper and deeper into our daily lives, figuring this out isn't just a tech problem, it's a challenge for all of us.